So today we are going to graph exponential functions and determine if they represent growth or decay. So now, what is an exponential function? An exponential function is a nonlinear function that grows or decays rapidly. And when we say it grows, it means from left to right, you'll see that it starts out low and grows real quickly. If it decays, if something decays, that means it starts real high and then decreases real quickly from left to right. Now, when we graph these exponential functions, right, the easiest way to do it is pretty much a table of values, right? And all I'm going to do is pick x values to plug in. So I always like to start with, say, you can start at x value of 0 or -1, -2, doesn't matter. I'll start here at 0, 1, 2, 3, and maybe I'll put a -1 in there. But the first thing we're going to do is if we plug 0 in, right, we're going to do 3 times 2 to the 0 power. In the calculator, that's going to give you 3 times 1, which is 3. So I'm going to go down there and I'm going to plot 0, 3. Okay. Now, 1. If I plug 1 in, 3 times 2 to the first, 2 to the first is 2. 3 times 2 is 6. If I plug 2 in, 3 times 2 to the second is 3 times 4, which is 12. And then if I do the next one, 3 times 2 to the third, 2 to the third, remember, is 2 times 2 times 2, which is 8. 3 times 8, 24. So if I plug all of these, or plot all of these points, 1, 6, what do we say, 2, 12? And what do we have, 3, 24? Now, if I wanted to work backwards here to -1, just let you know that's kind of going to be an ugly number. 3 times 2 to the -1. And you probably haven't done enough exponents yet to know that that's the same as 3 times 1/2, which ends up being like 1.5. So -1, 1.5. What you'll notice here, right, is this function will start out low and increase real quickly. Okay. So what I want you to know here is a couple of things. One, this here is my y-intercept. Does this value look familiar? Yeah, right there. Your y-intercept, if we talked about before that this is a times r to the x, right? Your y-intercept's always going to be 0, whatever that amount is, right? So your y-intercept is going to be your a value. Your common ratio is, what am I multiplying by each time here? 2, right? So basically your common ratio is 2. Now notice here for this one, for an exponential, this here is exponential growth, right? And that's because from left to right, it's going up real quickly. So as x increases, or as we go to the right, y is increasing. Notice, as x gets bigger, y gets bigger. Okay? Now for the next one, if I start at 0 here, okay, 0. I'm going to do 40 times 1/2 times 0. Anything to the 0 power is 1. 40 times 1 is 40. All right. So we'll plot that point. 0, 40. Now, if we go 1, that's going to be 40 times 1/2 to the first power. 40 times 1/2 is going to give me 20. So 120 would be my point. Let's do another one. 2. 40 times 1/2 to the second power, which is the same as 40 times 1/4. A fourth of 40 is 10. So 2, 10. Notice what's happening here. I'm dividing by 2 each time, so I know right away this is going to be 3, 5, 4, 2.5. So if I go 3, 5, 4, 2.5, what I notice it's going to divide in half each time. So as I move to the right now, oops, that's actually a really bad graph. Sorry about that. Let me redo that. Right? This is what that graph is going to look like. Okay. Now, when we start high on the left and go down to the right, that's what we call exponential decay. And as x increases, what's our y value doing? So as x increases, what's y doing? It is decreasing. So that's why we say an exponential function is a nonlinear function that grows or decays rapidly. We say A is your initial amount, or we could say that this is the y-intercept, 0a. Your B is basically your common ratio, okay? And it also tells us if it's going to be growth or decay. Now, if you notice here, B in the problem up here was 2. Oh, and then down here, B was 1/2. So the one thing we say is if B is greater than 1, it's going to be growth. If B is greater than 0 but less than 1, basically it's a fraction or a proper fraction or a decimal less than 1, it's going to be decay. So right away here, let's look at some examples. So when I look at this, if there's no number out to the side, so if I have a times b to the x, or I just have b to the x like this, that's telling me there's technically a 1 in front. So right away you have to understand this number tells me if it's growth or decay. That number, right? So in this case, b is greater than 1. Oh, sorry, b is equal to 7. 7 is bigger than 1, so I know it's growth. My y-intercept, I have to imagine there's a little 1 there. My y-intercept would be 0, 1. Next one, to determine if it's growth or decay. Is that number greater than 1? No, it's a proper fraction. If that number is less than 1, it's going to be decay. My y-intercept is always going to have an x value of 0. What's my a value? 8. Next one, if I look at this, my b is 4/3. You have to understand if I did that as a mixed number, that would be 1 and 1/3. So that's telling me b is greater than 1, which means it's growth. Now my y-intercept is 0. What's my a value? 1/4. And finally, here is this growth or decay. Well, I know 2/3 is less, 2/3 is less than 1, so it's decay, and my a value is 12, so 0, 12 is my y-intercept. So for the next few, I don't want you worrying about the domain and range. We're just going to worry about graphing it. Okay. So right away when I look here, I'm going to start by filling out, there's no number, there's no a value here. So we're going to say it's 1, right? So my y-intercept would be 0, 1. Since b is 9, 9 is greater than 1, I know this could be growth, right? And you also have to understand, since 9 is my common ratio, 0, 1 is my y-intercept, and I know that common ratio allows me to just multiply by 9 to get my ordered pairs. 1 times 9 is 9, times 9 is 81, and you can keep going. But I only need a couple of points to plot this. So I'm going to start with 0, 1, 1, 9, and I know it's going to be 2, 81, which is going to go off the charts. These right now, all the ones we work with, do not cross, right? The x-axis, so that's how our graph would look. Next one, right away, to find my y-intercept, I look at this a value of 4. So 0, 4. I know that right away. Now, I look at my common ratio is 2. 2 is bigger than 1, so it's growth. And I also know that's my common ratio. So if 4 times 2 is 8, times 2 is 16, times 2 is 32. And I'm going to go ahead and kind of just sketch a graph here. So I'm going to go 0, 4, 1, 8, 2, 16, now I know I could also divide to go backwards, so that'd be 2 and that'd be 1. So it'd be negative 2, 1, 1, 2. And if I go ahead and sketch this graph, here's how it would look. Okay. Remember, you can always pause the video if need be. Now, for the next one, my y-intercept is going to be 12. So 0, 12 right away is going to be a point. And I can actually go and just plot that right away if I wanted to. So we have 9, 10, 11, 12. Now, if I look at my common ratio, that is 1/3. So if b is 1/3, that is less than 1, so it's decay. And if b is 1/3, that tells me I'm going to divide by 3 each time here. So 12 divided by 3 is 4. 4 divided by 3 is 4/3. If I work the other way, though, I would multiply. 12 times 3 would be 36. 36 times 3 is 108. Right, so if I wanted to work backwards here, negative 1 and 36 is going to be somewhere up here. We said 1, 4. 4/3 is 2 and 1 and 1/3. And if we really wanted to graph this, our graph would look like this. Okay. Now, I'm not going to go through graphing. I'm just going to talk about the key points on the next one, right? When I look at this, you can use a calculator to fill out this table, but no one understands your y-intercept is 0, 24. And if I look at 0.75, 0.75 is smaller than 1, so I know it's decay. Okay, and then you could basically 0, 24, and then once you find the other values, you can plot them and know it's going to be decay and look like something like this. Okay, the next one, you know right away your y-intercept is going to be 0, 6. Now, your b value is 1.5. That is bigger than 1, so you know it's growth. So if I started at 0, 6, if I were to sketch this graph, I know it's growth. So it's going to start small on the left and grow really high. Okay? It's very important to understand if it's growth or decay. Go ahead and try the worksheets and let us know if you have questions.